Hello everyone, welcome to the Solidity Fundamentals course. My name is Anjali and I'll be your guide for this course. In today's lesson, we are going to discuss about transactions, their types, and the different accounts which can send transactions, receive transactions, the attributes of a blockchain transaction, and then practically view all these transactions on a blockchain explorer. First of all, what are transactions? So, transaction is an act of transferring Ethereum based assets from one address to another. So, this could be one definition of transaction. Since we are discussing the Ethereum blockchain, so I've mentioned Ethereum based assets. So, in very simple words, transaction would mean transferring some assets from one account to another account. So, they are cryptographically signed instructions and can only be initiated by an externally owned account. So, before explaining this point, let us first see what are the different types of accounts which can be present on a blockchain. So, there are two types. One is the EOA, which is the externally owned account, and the other is a contract. So, what EOA means? The wallet address or the wallet account. So, the accounts held by us. So, those accounts which are controlled by anyone with a private key. Since we saw in the on the MetaMask lesson where we were installing the MetaMask wallet, so there is a set of keys, public key and a private key. So, all those accounts on the Ethereum blockchain which have private keys are said to be an externally owned accounts, and other than that we have an account known as the contracts or the smart contracts which we deploy on the blockchain. So smart contracts can also, because smart contracts can also send or transfer money from themselves to other contract maybe, or to another externally owned account. So that's why contract is also a type of account, because it can also handle the transfer. So it can also transact. But there is an important difference between the two type of accounts, and that is that a transaction can only be initiated by an EOA. It can be received on the receiving end, it can be another EOA, or it can be a smart contract, which would mean in simple terms that as a person, as an account holder, I can send Ethereum ethers from my account to my friend's account. That will be a transaction initiated by me, cryptographically signed by me using my private key, and sending it to some other's account. But I can also send that money, initiate a transaction and send that money from my account to another smart contract, maybe to OpenSea for minting an NFT. So I can send money there. So I can always initiate that transaction because I have a private key and I can sign that transaction to initiate it. But the same is not true if you want to initiate a transaction from the smart contract. A smart contract, because since it's controlled by code and doesn't have a private key of its own, that is why it cannot sign the transaction. And that is why when it goes in the blockchain, so it goes for validation and verification. So there is no way of authenticating whether that transaction has come from an authenticated source. That is why transaction cannot be initiated by a contract. It can be received definitely, but it can only be initiated by an externally owned account. So that's what is the meaning, that transactions are basically an act of transferring assets from one account to the other account, but they can only be initiated by an externally owned account, which in this case means a wallet address. Now, talking about the types of transactions. So, again, we have a normal transaction, internal transaction, and token transfers. So, now you'll be able to understand it in a better way, because normal transaction would mean that an externally owned account or a person holding an account is sending ether to another person itself. So, there is no involvement of smart contract. That would be categorized in the normal transaction terms. Internal transaction means, whenever the word internal comes, I will show it to you in the blockchain explorer also. So there is a separate category for internal transactions. All those transactions which are initiated from EOA but goes to the smart contracts for starting a function, in executing a function. So because, since we know that smart contracts is made up of different functions, and those functions, they are executed only upon certain events or certain so EOA can do that, and that comes under the internal transaction thing. So if an externally owned account basically triggers a function written on a smart contract that is also considered as a transaction, but then that will be a type of internal transaction. Other than this, we have simple token transfers. So if you have an ERC20 token with you, or if you have an ERC721 token, and you have just transferred your that ownership of that token from you to others, so that is uh, maintained in a separate category, which is known as the token transfer transactions. So all the token transfers, they are shown separately, because since that they are the most frequent type of transactions which happen. Other than that, the normal transactions also happen a lot, where you're sending Ethereum to another Ethereum, or internal transactions where you are sending, where you're triggering the code of a smart contract through an externally owned account. Now, we've discussed this already, so this is just a quick revision that what is the life cycle of a transaction, and how does the transactions begin, and what is the complete process it follows until it is confirmed. First of all, a transaction is created. Created means, as we have discussed, an externally owned account or a wallet address will start a transaction by cryptographically signing it. Now, after the transaction is created, it is introduced to the blockchain nodes. All the nodes of the of the network, they are introduced with this transaction, and the transaction creator gets a transaction hash. So basically, imagine if I am trying to create a transaction here. So if I start a transaction, I will be given back a transaction hash by the network, which will be saying that you can now monitor your transaction on the blockchain explorer using this transaction hash. Now the transaction gets broadcasted to the whole network and then waits for a miner to pick it up and verify it. Now, so it's a complete process. I have started the transaction and I have received in return a transaction hash, so that I can keep checking the status of it, because it takes a couple of seconds for my transaction to get confirmed. And in the meantime, the transaction that I have created, it gets broadcasted to the entire network, and the miner, and it is waiting for a miner to pick that transaction up and verify it. Now, the waiting time depends on the network's current traffic and the gas fee set for the transaction. So, these are two very important parameters which decide the success or the confirmation of a transaction. One, network's current traffic. Supposedly, if that network is really congested at that time when you have created this transaction, so definitely there will be a competition between the transactions, and it can take more time for your transaction to be picked by a miner, right? And also the gas fee. So what happens is, as we know that we've covered this, that gas fee is the transaction fee, or gas fee is the basically reward which goes to the miner for verifying your transaction. So it depends, and gas fee is totally set by the user. So the creator of the transaction, the initiator of the transaction, has to set this gas fee. So if you have set this gas fee to a low value, that will be a lower incentive for the miner, definitely, and the probability of him picking that transaction would be low. So in case where you see that the network is highly congested, you see in MetaMask also, when you're trying to initiate a transaction, it shows you that depending upon the current traffic, that it is advisable to increase your gas fee, so that it has a high probability of being confirmed.